let's see. We are starting with homework. And by the way, this is like, I'm not sure if you're aware of this, but like there's this. So let me preface today's lesson a bit before we get into homework.
Okay.
So I'm not sure if you're aware of this, but like in programming and like people interested in functional programming, the first question they usually ask is, what's a monad?
Yeah.
Right. And I always like, and I really don't like that, because you kind of need all of this preamble in order to actually be able to start explaining this. Maybe you don't necessarily need this part, like records. That's kind of an optional thing. And maybe you don't really need recursive types, but like pretty much everything else you need it, right? You have to know types, you have to know everything, right? So it's kind of like there's no way you can explain monads earlier, right? And that's maybe that's one thing that's funny, right? Because people know nothing about FP, they want to get into FP, and the first question is, they explain me monads, right? And like, I can't, because I need to explain you types and sum types and product types and type classes and functors and higher kind of types, and then maybe I can start working my way through what a monad is. So anyway, last time we did higher kind of types and functors, and I think there was quite a bit of homework to do.
Yeah, there was quite a bit of homework, but again, I have problems. I know how to think the exercises, but I don't know how to solve them from a syntax viewpoint, you know?
Okay. Yeah, no problem. Also, hello, Divine Masaya. Yeah. You can definitely ask a Haskell question, and if there's a lengthier answer, then I'll wait for after the homework is done. If it's very simple, then I'll just answer it immediately. Okay. So I guess let's get going then, because I can only stay for 2 hours. So let's see how much we can get done. Okay, yeah, sure, no problem. Just delete those.
Sorry. Yeah.
I think this is correct. I'm not sure why it is
different declaration.
Oh, okay. I see why the problem is. Do you see what the problem is?
It says that there's a list length.
So the way Purescript is interpreting this is, okay, this, when it's taking nothing, it returns false, and then this is taking just and something else, right? It's not treating this as treating these as two separate things. So you need to parenthesize.
Yeah, okay. Yeah.
Like you always need to parenthesize when you're pattern matching constructors.
Yeah.
On the left hand side of equals. But other than that, this is exactly correct. Good job. Okay.
And then I tried to do the next one in different way.
That is actually correct. What is the problem here? Oh, okay. So okay, it's complaining that you deleted the type signature and you don't have a type signature, right? So it wants it's right from for all A B, either A B to Boolean.
I had it, but I didn't paste it for some. Yeah.
Think that's what no type declaration provided. What? Hello. Okay, there we go. Figure it out. Okay, that's good. Okay, good.
And this is where I start some questions, because I don't really understand. And now I copy it, of course. Okay.
Oh, this is exactly correct.
Okay, so yeah, this is I even wrote myself something. Okay, I wanted to ask you if I have to pattern match as whole. If I had to add the right one as well.
No, you don't.
But no, yeah. It made the most sense to leave it like this.
Okay, I think it's correct. I think it was, length different. Oh, again, the same problem as earlier. With the just X here.
Just X. And I have to parentheses.
Yeah, that's the problem. Like whenever you see the different argument length problem, it's almost always that.
It says that nothing is not typeable.
What? Left missing. Oh, okay, because I actually wrote the wrong type here for you. It's absolutely my bad here. It needs to be a string here for it to work. And we need this here. Okay. Actually, I had a... Yeah. That's my bad.
Okay.
And then also here is also my bad. So this needs to be string here. Okay.
Okay, yeah. I mean, this is just the opposite of here. I have to do it here as well, right?
Yeah, I think this is correct. Let's save it and see if it compiles. Oh yeah, again, same problem here.
Yeah, no string.
Yeah, so this actually exists. Well, actually, no, you don't even care. Yeah, I should have wrote it like this, right? Like, it doesn't matter what you have there, right? So in this case, this is correct, actually. So, like, here you just need to do this, right? You don't really care what's on the left, you just throw it away.
Okay.
Right, you don't check that it's equal to... I don't think you can paste a lot of code in chat, so maybe you could use a gist or something, and then we can have a look a bit later. I didn't read your full question. I'm waiting for the homework section to be done. Okay, so let's see.
Okay, this is where I
length nil is 0, and then here. Okay.
So I'm pattern matching, and I know that I have the x, like the first element that I'm taking from the list, and the rest of the list. And now I have to reconstruct the entire list.
Why? Because you're just taking the length. You don't have to construct a list. You need to return a number.
Yeah, but again, I looked in. I tried to find something that we did like this before, but I can't seem to find it in my in all of the lessons. Yeah.
So I think it should be here, or even lesson 3. I think we should have different length implementations here. It's count. It's the same thing as count. I just gave it a different name.
Yeah. Okay. Yeah. Okay. So well, now I already know the answer. Because
okay. Let me see.
I have to do this.
No, you just need to do rest.
I just do the length of rest.
Yeah, that's correct. Yep, that's it. Right, and like you don't even like the trick here is like, or the idea is that you don't even have you don't even care that there's what type of A's are there, right? We're not even looking at the A's. We just count how many cons there are, right? And then use nil for 0. Yeah. Okay.
The index is a bit too. The next 3 functions, I think, are
they're definitely harder than the rest.
Yeah, but it's still frustrating because I feel like I should be able to do them, but I kind of fail.
So did you try something, or did you just not do anything?
I did, but I actually deleted most of it. It just doesn't make sense.
Okay, so let me try to explain it to you, like step by step, because maybe that's the best thing we can do here. So let's start over. So we have so we want to take the nth item from a list, right?
Yeah. So
the way I think about it is, it's kind of like, okay, so what's the condition? Well, the condition basically is I need to, so okay, let's take the simplest example, this one, right? So if I have a 0 here, and I have nil here, then I cannot give you any value, right?
Yeah.
Like there's nothing that I can give you. Okay, but if I have 0 here and counts x and something else here, then I can give you x, right? Because like this is kind of the termination condition.
Yeah.
Right?
Okay. Yeah.
And then if I have some value, some number n, right? And I have whatever, well, not whatever, and I have counts x and x's here. Well, I don't even care. Some rest here, right?
Yeah.
Then I need to go to index of n minus 1 and rest. Does that make sense?
Yeah.
So I'm basically decreasing this, right?
Yeah.
And at the same time, like decreasing the list, or like making the list smaller. Right, and like I remove one from here, and then I remove one from the list until I reach 0, and this will do terrible things if you give it a negative number, but I don't care about that. Okay, we can definitely have something like index n, and then whatever, and then we can say something like I mean, the thing is, it gets uglier if we do that. We could do something like here, right? If n is smaller than 0, then we do nothing, right? We don't even care, and otherwise we just do this, I guess. So it's not that bad. We can do this, right? And then we also what's the problem?
Other W. Oh yeah.
Right, and then it's like, okay, it's not that bad actually. And then we have one more case.
Yeah, the empty end.
The like n and empty, right? But then I guess like we don't even care what's here, right? If we've reached the empty list, we can never do anything, right? Like even if it's 0 of any n number, if we reach the empty list, we can't ever give you a number, right? So it's always nothing.
Yeah. Oh, since I couldn't do the index, actually, I don't know how to implement the fold with the double B in the function.
Okay, so let's also take. So do you have something, or do you want to try
No,
it?
no,
Okay.
No, this one.
Okay, so here what the trick here is. So let's see. We have. Okay, so first thing is we need to look at this. Okay, so the only thing we can do is pattern match on the list, right?
Yeah.
Do you agree? Because there's nothing we can do with AB. There's nothing we can do with this function. We call it f, right? So we can only pattern match on the list, right? We cannot pass this to this and obtain a result, right? We also need an A.
Yeah.
Right, so there's nothing we can do here. Okay. So let's say, okay, so let's pattern match. So if we have a nil here, right?
Yeah.
Then what can we do?
We take the function A to B to B.
But we don't have an A, right? We need to return a B. We have this function and we have a B, so we can only return the B that we have.
Oh yeah, okay.
Right?
Yeah.
Okay, so what if we have this and counts x and rest? And let's even call it A, right? Because it's of type A, right?
Okay.
So what can we do here? Well, we could also do B, but that's obviously wrong, right? Because then it will always return this regardless of what happens.
Yeah.
Right, so okay, this is not right. Okay, so we need to do something else.
Okay.
So we have an A.
Another name. Okay, sorry.
Now we have an A, right? So we can do f of A, right?
Yeah.
But now we also need to give it a B. Well, we have a B, and we could do this, for example, which would compile, and it would be like it would sort of compile. But what would happen here is, so let's look at some example, right? So let's say we have fold of 0 and plus is the function here. So in this case, B and A are the same type, they're numbers, right? Okay, and then we give it the list of 1, 2, and 3, right? And we expect the result for this to be like 1 plus 2 plus 3, right? So it's 6.
Yeah.
But in our example here, right, what was the result? Well, so we have this thing, right?
Yeah.
So B will be 0, F will be plus, right? And kind of replacing these things, right? And then we'd have counts of 1 and the list 2 and 3, right?
2 and 3, yeah.
But then it will be equals to plus of 1, right? And 0, which is 1, and it stops. So it's not right. So we cannot use B here. So here we just do this fold of B, F, and then rest. We do the recursive thing. Right? And this is the way to do it.
Okay.
But again, it's kind of harder, right? Because you have to like write an example and think about it and like reason about it. And again, I
tried replacing them, but it still doesn't make sense quite yet.
So,
I mean,
yeah.
when you explain it, it does make sense. But when I look at it by myself, it just doesn't.
Yeah, I guess I really want us to go to finish with monads, and then hopefully you can start writing your functions. I need to help you to be able to run things locally as well. And after we're done with that, then you can play with things, right, and try things out, and maybe that will make things easier, I hope.
And this one. Nice.
Okay, so this is very similar to this.
Yeah, except we also have the empty.
Well, like we have the monoid, right?
Yeah.
So actually this is, well, if you feel like, if you like having this is actually quite easy because we can do fold.
Yeah.
Like we can use this function, right? And then let's take some list L, right? So we can fold. So what operations do we have for monoid? Well, we have the A to A to A or M to M to M, right?
Yeah.
And we have empty as the empty value. So we can do just empty and then this and then list and that's it.
Oh.
Right? Because we have this operation, but it's M to M to M, which is fine. And we have an M, right? And we have we need the M as a result, right? So this is actually I guess this is easier than this in a way, right? Because if you would be able to figure this out, then maybe this is not that hard if you had time to think about what's inside monoid, what do I have, and so on, right? It's kind of like figuring out that A can be the same as B, right? And then which is M, and then if you replace M everywhere, then maybe it's a bit easier to see, right?
Yeah.
If you have M instead of A and B everywhere. Okay, so were you able to write any functor instances?
Yeah, I have some questions about functors as well.
Okay, so let's see functor, and then use this thing. Okay, so let's oops. Okay.
Well, this is just
the next one. Okay, let's look at this then. So so there's a misspell there. Okay, so what is the problem?
A0 to B1.
Huh? Wait, what's the problem? Match identity with function. I'm actually not seeing what the problem is. Give me 1 second. So cannot match identity with type function A to B. Oh, okay, I see. You have an extra A here.
Yeah, okay. I thought I also have to give it the A. That's
no, because the A is inside identity, right? Look here.
Yeah,
like it's
yeah,
inside
yeah.
here.
Okay.
Like identity is really like identity of int is just an int, right? Or identity of string is just a string. It's just like a layer on top of it, but it does nothing actually. Right? Okay. Okay, so let's see. This Purescript looks exactly like Haskell. Well, I mean, this small difference here that you need to give instance, need to give names to instances. But I think that's the only difference that we're noticing right now. And you have to do explicit quantifying. Like you have to use explicit for alls. You cannot have them implicit, but that's pretty much it. Like at least this part. Okay, so.
Okay, so I didn't really understand how I'm supposed to.
Again, this doesn't need
translate.
to be here.
Yeah.
Okay.
I wanted to delete it afterward. I didn't fully understand how I'm supposed to translate.
Okay, so first off. Okay.
Yeah. Okay. Go ahead.
So first off, the type pair has only one A, not two, right? So it has to be just this. And also, usually you just use B because then it's a lot easier to read, right? And you also have AB here, so.
Yeah. That's what I wanted to ask you. Like, how does the double A on the right work?
So okay, this is the type.
Yeah,
and here you add types, and then constructors is when you pattern match, right? But you cannot have constructors here, right? So here you can only have the type, right? So it's a single A here, right? This is kind of like, okay, so how would a value of this thing look like, right? It would be something like pair value, and it's pair int, for example, right? You could say pair 1, 2, right? And this stores 1 and 2, right? You can store 1 and 2, and then you can get back the first value, get first, and you'd say from a pair int, I want to get some int, and get first would be pair x and whatever equals to x, right?
Yeah.
Okay.
Okay. I see it.
Okay, so this like what are the inputs here? Like look at the function.
Yeah. Well, I can only use the A and the.
Well, no, like what's the first argument there?
It's A to B.
Okay, and then the second.
And then here is where I have to give me 1 second. It's A to B of A, right? It's actually I have to pattern match.
Yeah, exactly. Have to pattern match. Yep. But then, like,
and
like
I have to, yeah.
Like
and
it's A1 and A2, right?
Yeah.
Okay.
So I. And.
Okay. And then what do we have to return? Like,
I
what's
have to
the return?
return the pair B. So
right. So start with pair, right? We need to
Yeah.
say pair.
And
Okay.
okay, this is my question
Mhm.
because my head tells me that it's this.
Okay. No, but like, what about the other argument? Because then it will say like a pair needs 2 arguments.
Yeah, and
Well,
it
but this is
also needs-
A1 or A2? Like, which A is this?
that's what I wanted to say. It's
Okay.
And A to B, A2, but how do I say it?
Also in parentheses, like this.
That's all?
Yep.
Oh.
Is that easy?
It's I think actually.
Because like the thing is, the thing here, I'll reply in a second, Anka. So the thing here is that if you go from pair int to pair string, for example, by using the show function here, right?
Yeah.
Then like you're holding 2 integers, but at the end you have to hold 2 strings, right? So you have to apply the function to both of them, right? Because otherwise, like you can't hold a string and an int here. They have to be the same type, right? So that's the idea here.
Yeah. Okay. Oh, I don't know where I think it's in a no. But I actually messed around a bit with these ones, and because I don't know if the result is correct or not, I just kind of, it felt like what I did was wrong anyway. So I didn't.
So can you have? Oh yeah, it can cause so much confusion, and we've avoided that until now. But I kind of wanted to get him used to it because it happens quite often to have the same name for type and constructor. So it's something that you need to get used to eventually. So you cannot exactly. Chug salt is correct. You cannot have duplicate instances. So the names are just. I think the plan is to remove the names at some point, but they were useful. They're useful because you'd see them in the generated JavaScript code, and then you'd know which kind of instance is being called, which would be quite useful when you're doing debugging or trying to understand the JavaScript code. So yeah, but you cannot call them by name, not in TypeScript. You can probably find them in JavaScript by name, but yeah. And then sometimes I feel like I agree that especially if you're a beginner, you should probably use that. Like you should probably rename the constructors to like make to pair or whatever until you're very comfortable with the distinction between types and values. Okay, that's good.
Okay, so here is where I need the 2 pair of A and it goes. How do I need?
Okay, so here's the almost. So here's the trick. The thing is, like functor can only change the last one. You cannot change both.
Yeah, I remember. Yeah.
So then
it would be.
So then, okay, one thing you need to do is here we need to give it a name here. So let's say X, right? And then we have to use X here and then here, right?
Yeah.
And then we have to say X here, and then we go from A here to B here, right? So it's very positional, right? So oops, this one. So whenever you have a type like this, right? So because until now the type only had 1, right? Even if the constructor has 2 arguments, the types only had 1, right?
Yeah.
So if you have more than one, then you need to give names to all but the last one, like whatever name you want, right? You can you can do potato here or whatever, right? And it still works. But like you have to give names to all but the last one. Hello, Didi. And then you kind of like you have to write like to kind of apply it here, right? So it's x here, the first one. It's always x. You cannot change it with these functions, and you only change the last one, right, from A to B.
Okay.
Okay, so let's see if we can implement it.
So next I need the function again with
Yeah.
A to B. Now I have pattern match.
So just say x, right? Because it's some value of type x. It doesn't matter. And then what type is that? The next one?
And A. Right?
Yep.
And it equals with pair. And this is where I get.
So what's the first thing that needs to be here? Look at the result type.
It's the x.
Yep. And we don't touch the x, right? That stays as it is.
Yeah.
Okay.
And A to B of. Is this correct?
Almost, but like these are two different arguments, right? So it has to be like this.
That's where I was going. Yeah.
Okay, and I think it's correct.
And now, but it's not over yet, right?
Yes, it is.
Yeah, okay.
Right, because we're done with the type. It's an x and a b, right? Here, and then like here, the tricky thing is like a becomes x and b is a here and then b here, right?
Yeah.
So you kind of have to do this sort of like renaming in your head, right, as you're looking at this. If it's hard for you, the example, okay, so let's try this. Let's do w, x, x, y, and z here. Oops. Right? Just so they don't clash. That map is called, like, you should look into bifunctors. That's, I think, a left usually is what it's called, where you map you use bifunctors to map the left hand, like the left argument rather than the right. Yeah. Okay, no problem. Like, look into bifunctors. I think they're in base now in Haskell, so I think it's called first. I hope I'm not, I don't have the wrong name, but just look for the, okay, LMAP and RMAP, okay. I guess first and second are for profunctors, for like the strong profunctors or something. Yeah, I mess this up usually. Okay, so okay, wait, you're mixing up the syntax. So you have to do functor, name, and then where first in the instance, like in the first line.
I was so caught up in this that I was already going, yeah.
So like write this thing, right? So 3 pair, and then how many arguments do you need to, wait. Like this has 3 arguments, right? This had 2 and we had to fix 1, and this has 3. How many do we have to fix here?
Oh yeah, but I did this here, but then I just, yeah.
Okay, so yeah, that was right, that part. Okay. But I would probably not use A and B. I would use X and Y or something. Okay. Okay. That's good so far.
And now map for X, Y, and Z. X and Y, because.
So you need X and Y, but you also need the N B always. We will always need the N B. Okay. But like you can write the for all at the end and see what you use later if you want.
Yeah, that's what I was thinking. Yeah.
Okay.
And now, does A go to B and goes to C?
No, it's just A to B. Like functor always, like in functor you always have just A to B. There's no way to change this.
Okay.
Yeah.
And okay, so this is where I didn't. I did.
Okay, I mean then just do arrow, right? We have to do the arrow, and then we have to go to 3 pair, right?
Yeah.
And then the algorithm is you just exactly, and then the last one has to no parentheses. No.
Okay.
Like there's no parentheses needed. Like it's like here, right? 3 pair needs 3 things, right? It's X, Y, and then we use A here for Z, right? Like we used A here for B, and then we also do arrow, and then what's the 3 pair? Like what do you think is here?
This would be X.
Yeah.
Y. and instead of B, I would have the.
You mean instead of the A here?
Yeah. Instead of the A, I would have the Z like this.
Well, there's no Z. You just have the B, right? So that's the idea. Like you're
Okay,
changing the last argument from A to B.
From A to B. Yeah.
Right? That's the common pattern here, right? And if it's just one, it's obvious. But if it's more, then it's the rightmost, the last one that gets changed, right?
Yeah.
Okay, and then let's try to implement it now.
Okay, so B of 3 pair. It's X, Y, and A.
Yep.
And I go to 3 pair.
Yep.
Of X, Y, and A to B of A.
Yep, exactly.
Yeah, now it makes sense. Yeah.
Okay, cool. And this is actually like compilers can do this for you. They can handle it automatically, but it's good to understand. Yeah, it's good to understand how it works behind the scenes. Okay, let's try this one fast, and then we're done with the products.
Yeah. Okay.
So let me help you here. So let's do again X, Y, right? And then wait, what was it? Oops. I think we both did undo.
No, I didn't.
Oh, okay. So let me. Okay. This is weird. Okay, so I think it was AB here, right? So
yeah.
This is X, and this is Y, and this is Y, I guess. I mean, either way is fine. It doesn't really matter. Both will work. They'll just be a bit different. Okay, so let's try writing the instance.
Let's write the instance where I have other pair functor.
Oh, I actually missed it. Hello, Romania hate. It's been a long time since I saw you. Yeah, I changed my schedule to stream a lot earlier. Okay, so it's other pair of. So how many are there in total? There's 2, right?
I only have 2. Yeah.
So what?
It's X and Y.
No,
it's not Y because it should be.
We need to keep one. Yeah, we need to keep one free, right, for the A to B thing.
Yeah. So
right?
it's B.
No, it's nothing.
It would be A because.
No, it's nothing here. So look at this. If it's 3, I just add 2 and leave the last one open here.
Okay, yeah.
Right in this spot, and then only in the next line we need to start to.
Yeah.
Okay, so it's.
So I need X, Y, and A and B because I'm
okay.
Gonna move.
We'll see. Okay.
Yeah, we're gonna find out.
So we have other pair, right? Okay, yeah, right. AB, yeah, you're right.
And now I go to other pair.
Okay, so like first thing you can just write this, right? Like the thing you have
said
here.
I can just copy the X.
Okay, and then like the next thing is yep.
And now I go to other pair of X and B because I can only change the last one, so it goes from A to B. Yeah.
So you didn't end up needing the Y actually here, right? We'll remove it.
Yeah, yeah. Okay. And now get the function into B. Of what is here? It's X and A.
Well, not really. So this is a trick. So you're looking at the type, but when you're looking at pattern match, you need to look at the constructor.
So it's X, A, and.
Oh, this is tricky.
Or is it the other way around?
So so it's actually this is X and this is Y, right? So in our case, this is X and this is A. So the first one is A, the second one is X, and the third one is also another, but it's a different A, right? It's an A prime or A1 or an A2 or whatever.
Yeah. Okay.
Okay.
Yeah.
So now what are we building?
I'm building other pair.
Okay, but now you have to look here again, right? So we kind of, or maybe even here, right? So
I know that I need 3 of them inside of it, but.
So here we used to have an A, but we can no longer have an A, right? We need a B.
To be a B.
So how do we do that?
Do I go A to B of A?
Yeah, but put it in parentheses. Okay. So next thing has to be an X. Do we change the X in any way?
No.
We cannot, right? And like the third thing that also needs to be an A. Well.
So.
Okay.
A to B of A prime.
Yep, and also in parentheses. Yep, exactly. Right, so like the algorithm is every A's you need to like apply this to them, right, wherever you find them, and then everything else stays untouched, right? So this is correct.
Yeah. Okay. I had. I'm sorry for this, but I had kind of a hard time understanding the functors.
No, I don't think
on
we
my
did
own.
enough examples together, so
Yeah.
I think we needed to
Yeah.
do a few more. So that's
I mean,
totally fine.
we did like 30 minutes, but it just wasn't really enough for me to get used to it. So, okay.
Okay, so let's try doing this one, right? The sum, and see how this turns out to be. So the function you call comap is a contravariant functor. It will be called contramap in Haskell and CMap in Purescript. A co-functor is just a functor, so comap would just be map. Well, I mean, actually, also in category tier, right? Contravariant functors and functors are both functors. Like, there's no real distinction. The thing is, they turn out to be quite different in these languages for some technical reason. But yeah, I don't think it would be necessarily wrong to call them comap, but it's contramap. That's way more the more obvious name, because it's for contravariant, right? Okay, so we have A to B again as usual. Wait, so here you don't do A, right? It's just someone.
Yeah,
right? Because it's
can
one
be
argument.
and 2 as well. Yeah.
Well, no, but that's not why. Like, look at pair, for example. If you have a single argument, then there's no argument you need to remove from it, right? So you need to add arguments until you reach one left. But if you're already at one, then you don't need to do anything. Okay. So what's the input is someone of A, right?
Someone, yeah.
And then it goes to
someone of B.
Yeah. Okay, and here's where it's a bit tricky. So okay, the first argument is obviously the function, right?
Yeah, it's A to B.
So now I have to pattern match. So how do we pattern match?
This.
Okay.
I know that it's. Oh, okay. So how do I pattern match this one? Because it can be 1, 2, or 3 of A. Right? So
okay. So what if it's 1 and it has no other value? We need to do equals, right?
Yeah.
Okay, so we have to produce a someone of B, and we have a function that we cannot use and a value. So what do you think would make sense to write here?
Someone. Oh.
That's not the name of the constructor. It's the name of the type. You need to use one of the constructors.
Yeah, it would be 1.
And that's it.
A to B.
Because what do you do A to B? Because you don't have an A.
Yeah, I don't have the A. Yeah.
Right. So here it's actually like this, right? Like you don't even need that. Okay, but then there's 2 more cases. Thank you very much for the follow, Dalmar. Let me see, because I think something has. I'll switch the window for just a tiny second. I need to restart something, but meanwhile you can definitely. I think this thing has crashed. Let me start this. Okay. Okay. Never mind. Next shell, and then start this. Think it should be running now, but I think that error might crash it. Let's see. It's still not working. Okay, so 1 is 1, 2 is 2, and then well, you forgot, okay, so what? Okay, and then you where's the function? Because you need to also. Oops, what did I do? Okay. Here you need to do A to B, right? Because we've ignored it so far, but we need it here.
Yeah, okay.
And you have an extra parenthesis. Yep, definitely.
Yeah, and I wanted to remove the parenthesis.
So yeah, it's something like this, right? Where we have 1 and 2, right? Which there's nothing we can do, but we have to keep them, right?
Yeah.
You cannot say 1 equals 2 and 2 equals 1. I mean, you can, and it will compile, but it's obviously not the right thing to do, right?
Okay.
So we need to keep the structure, and then whenever we can apply it, we'll apply it, right? Okay, so this is kind of brings both things together, right? It's something that has more type variables, but also has more constructors. Let's do X, Y, and Z just to X, Y, and Z, just to make it a bit easier for you. Okay. And I think it still doesn't work. Give me 1 second. I need to find a version which didn't have the bug. Is it this? No. Okay, sorry. Trying to fix some code while we do this. Okay, so let's see.
Fine.
X and Y.
I do have one
it's
question.
correct so
If this
far.
is- Okay. I wanted to ask if I have to add this if it's
No, yeah, that's
like
correct
three
so far.
different constructors. Okay. Okay. So
There's
again,
the function. Yep.
I go some two.
Okay, so what do you have there?
Should it be like
Yeah, that's correct.
right, this one? Oh.
Yep,
Okay.
that's correct. So now we need to we kind of followed this idea here, sort of.
Yeah,
Right.
but can I? I think I don't need the Z here.
Yeah, you don't.
Y and AB. Yeah, this is. And map prime is again function.
Okay.
B of. Do I care about it? Because first it's.
Don't worry about it for now. You'll see later.
Okay, now I have to pattern match. So this of X.
Well, is it an A? What type is this?
It's an X. So why do I make it an A?
Okay.
And it should equal do I just save it? So that means that I don't care about this?
Yep, that's correct.
Okay. Well, this applies to that as well.
Yep, that's a good observation. It's exactly the same thing. Okay. Okay, and now?
It's A to B, and now I go to other of Z.
Sure,
Z?
but is that of type Z?
Of type A, because this is what I'm changing.
Yeah, because Z is actually A in our case. Okay.
It equals other of second A to B of A.
Yep, that's correct.
This should be.
Yep, and it compiles. Cool. There's also one way to make these things shorter, which would be we could remove these two things here. We could say like whatever else, so like we could say T equals to T here, and then we don't need this. And it still works, but I don't like that. Why don't I like that? Well, what if we add a new type here, right? Some other and it works, but like you don't know that it works, right? Like it's a bit trickier. Like what if it's like I kind of prefer to get the error, right? So I usually just did this, like you wrote it. I prefer explicit pattern matching.
Okay.
But that would also be correct in most cases. Okay. So we have the last one, which is a recursive type.
Yeah. Okay, so
I'll still switch for a second. Of course, it's a problem here. So actually, I think the easiest way is just not calling the, Okay, so let's see. Oh, you're replacing them.
I
okay.
have one question. Yeah, can I replace those?
Well, no, because like look at the type. Type only has one, so they're all A, right?
It's only A. Okay.
So everything is an A there. So you don't even
so
need
for
to.
all A's and B's, I guess I'm gonna need an A and B as well.
Yep.
So I go from A to B again.
Yeah, that's good. That's good. 3 of A.
My cursor was in the way.
Okay. Goes to
3 of B.
Okay, cool. Okay, so now I guess so. First thing to notice is it's a sum type, right? So we need to pattern match, right? So let's get rid of the simple case, maybe.
Okay.
Like the empty case.
Yeah.
You don't need to parenthesize when it has no arguments.
Yeah.
Okay.
Right. And this is.
So you have three things, right? So you have a left, you can call it left, for example, for the left part, and then A, right?
V for value, like you said. Or
okay,
even
but yeah, we can use A and then right.
Right.
Okay. Yeah. So we can do equal. Okay, so how do we start? So we need to create a tree. So how do we start if we want to create a tree?
With the, do I map it again?
Well, no, because then you'd end in an infinite. Well, not tree, because tree is the name of the type, but like it's either node or empty.
It's a node. Yeah.
Okay.
Actually, I don't have to parenthesize. Yeah.
Okay, so
I should have a. This is the left one. So
okay, what type is left?
Left is an A type.
Well,
it's a tree of A.
Okay. So then
it's a tree.
Yeah, it's a tree, but it's a tree of A's, right? But we're trying to create a tree of B's with node, right?
Yeah.
So then we also need to convert this subtree of A's into a subtree of B's, right?
Yeah. So I have to map inside the left side of the left part of the tree.
But like you forget, like, so what's map? Map needs a function and then a tree. You're passing the tree directly, so you also need to pass the function to map.
Map of is this correct?
Yeah, that's good. Okay, so now we've done with this part, right?
Yeah, and now I need the value, which I guess still needs to be mapped, right?
Exactly.
Because,
well, no, right? No. Like you have an A and you need to have a B here, right?
Yeah.
So
it's A to B of A.
Yep.
Yeah,
exactly.
It's a simple value.
Okay, so what do you do? The right part now?
I do the exact same thing. What I.
Exactly.
Yeah.
That's exactly correct.
Look, I'm really sorry if it feels like I'm a bit slower, but
no, this is fine.
The syntax is really new to me, and
no, this is my fault, because we've done very few examples. We've done like 3 examples, and I gave you a ton of homework, so we should have done a few more together. Because like it seemed like after we've done like the pairs, you kind of got it, right? And then of course this is a bit trickier, but again, this is the first recursive one, and we do together, right? So it's obvious that it'll. Yeah, no, you did great actually.
Okay, thank you.
Okay, give me 1 second. Okay, so this silly thing built, we need to copy it, and then I need to run it. Okay, I think we should be done now. So binary and then this. Okay, this should work. Let me test it. Cool, now it works. you get the notification now as well. Thank you very much for the follow. Yeah, my brother tried hard, did some try hard there, and did like a cool notification animation, and I broke it, so I felt bad not fixing it. Okay, cool. So that's functors. So let me try to stumble my way into explaining applicatives now. So let's do part 7, and let's start writing some things here. So. Okay, So what was the what am I even doing? Okay, so what's the idea here? So we've seen functor, and let me, oops, I hit my green screen. Okay, so let me actually, let's copy the functor type class again here, because it will be, where is it, functor? Okay, there we go. Let me copy it and paste it here. We'll remove this part. Okay, and then I guess I'll just use this, like I'll comment it, right? Because we already have it. I'm not going to do it again. And I think I told you, but I'll repeat it. So in Purescript, this is the same thing, but it doesn't have this thing, right? It's functor and map without this, and there's already a lot of instances that exist, right? So we'll just use this. And also, okay, one more thing I want to tell you is, like, if we do data, I don't know, like identity A equals identity A, we can do derive instance K, and then Purescript automatically does this for you. Right, so Purescript is able to automatically derive functor instances for pretty much any type that you would be able to do manually. There are a few minor exceptions, but don't worry about those. It's a weird edge case that it doesn't matter right now, right? So this is like Purescript can do this for you. So like you'll almost never write it by hand, right? But it's important to understand how it works, because Purescript cannot derive everything for you, right? So okay, cool. So like we have this example here, stun attacks again. Yeah, it's crawling. It's here now, and then it will soon be in my face. So. Okay, but this type will not be very, very useful. So let's do like a what's a good? Let's do pair, right? Okay, and then let's do also like derive, or let's do maybe, because this is at least useful, right? So functor maybe. Oh, sorry. Functor maybe. Okay, cool. And again, as you can see, no complaints. Purescript can do this for you, right?
Okay.
And you can even test it, right? You can say test, and if you give me just a maybe string, you can say test equals to map. You can use the show function if you remember it's from int to string, right? And you can just do just one, right? So it will use this function which goes from int to string inside here, right? And it will transform this maybe int into a maybe string, and it doesn't give us a type error, so it's correct, right? Because if we write int here, then we'll get a type error saying, well, this isn't int, this is string, right? So so it works, right? The map function exists, and we can use it here. Okay, so now there's this other thing. Being able to derive functor instances is really cool, interesting. Yeah, it is really cool indeed. And like Purescript can derive a few other things, but we'll worry about that later. Okay, so then we have this class. Well, before so let's see, how do I actually explain it? Okay, so let's say we have two numbers, right? But unfortunately, due to unforeseen circumstances, both numbers are inside maybes, right? So let's say n1 is some maybe int here, right? And we'll just manually say it's just one.
Okay.
Right? But like, let's say that like we do this for simplicity, right? But let's say we read them from a file, and then what if it's in the file there's not numbers, there's like strings, and then we have to use nothing as an error or something, right? So it does happen, right? In practice quite often that you have two maybes that you want to use an operation over, right? So let's say we want to do a sum between them, right? And we just want to add these two numbers, right?
Okay.
Well, like how do we add these numbers? Because we cannot say n1 plus n2, right? We'll get an error because like plus works on ints, not on maybe ints, right?
Yeah, we have to construct them first, right?
So okay, one way is indeed we can pattern match. You can do something like case n1 and n2, and you can do this, right? You can pattern match on two things at the same time like this.
Yeah.
And you can say, okay, if there's just and let's do n1 prime or something, right? and n2 prime. Well, like this, right? Both need to be just. Then we can do just of n1 prime plus n2 prime, right? Does it make sense? And in in any other case, you just do nothing, right? There's like we can't add them if we don't have a value, like values. And it turns out this thing is something that happens very often, right? Like, what if we have two strings and we want to concatenate them? Well, I mean, let's see, right? Let's actually write that as well. So let's say we have a string here, and let's call it S1, right? And just do hello here, and then let's do S. Assume none is 0 and return. Yeah, sure, but like that's a different way of doing it, and that's a different sort of abstraction. But so let's do 2 is the world, okay, and then we can do like concatenate, which is maybe string, right? And we could say case S1 S2 of just S1 prime S2 prime just S1 prime S2 prime, right? This makes sense, right?
Yeah.
Well, of course, this also needs to be just here, and then if in any other case, then we return nothing, right? So like if we what did I do wrong? Kind of should be follow. Oh, I mistyped here. I added a J for some reason. Okay, so and if we look at these things, they kind of look identical except for this, right? Okay, so then let's kind of try digging a bit deeper. Yeah, thank you. I think there's some delay with the stream. Thank you, Ankado. Okay, so let's see.
Okay, I get. So I have one question. So the applicative is basically I can take this sign between the n1 prime or s1 prime, and I just decide what to do with it based on what the type of the.
So sort of. That's something you can do, but that's not how applicative looks like. But that's something you can do with applicative. So now let's actually try implementing sum in a different way, right? So let's look at let's do sum prime for example, right? Maybe end. So let's see sum prime. Okay. So what if we would what happens if we map the plus function over n1? What kind of type do we get if we do this? And maybe let's do this, right? Because let's look at the types for a second, right? So we have a n1 of maybe int, right? We have an n2 of oh, hello Barry, hello, and n2 of maybe int, right? And we have this plus, which is int to int to int, right?
Yeah.
But we also have map, which is something that if you give me a function from a to b and a maybe int, I can give you a maybe int, right? This is the map for ints, right?
Yeah.
Okay. So what if we do map of plus over n1? What happens here? What type is this? Well, let's try to. Okay. So maybe. So let me think. So what happens if you have this actually here, right? Is the question. Should I show in the REPL or should we? Oh, and the sun is again attacking me, viciously attacking me. Let me try to scoot over a bit. Maybe that helps. The game is rigged. Teacher knows everything. Let me think for a second. What happens in this? Like, how do I explain this best? Yeah, okay, so let's see. So, okay, do you remember, like I told you that a to b to c, like a function like this, is actually something like this, right?
Yeah.
Okay, cool. So let's say that, so our function is like this, right? Int to int, right? The plus, right? Okay, so let's say this is a here, right? But this whole thing is b, the whole parenthesis, right? So then we have maybe a goes to maybe b, right?
Yeah.
So what does this mean? Well, if we do map of plus, it would go to maybe int. Well, sorry, map of plus, right? It would be something that goes from maybe in, and we give it the maybe int, right? Like when you try to replace this, but the result will be a maybe int to int. You'll have a function inside this. Does that make sense?
Yeah.
Right, because when you do map plus and n1, right, this turns out to be like it's that function, so it's int to int to int, which is the plus, which is correct, right? So we kind of, this is the plus, right?
Yeah.
But then, like, the result of this is maybe int to int instead of a maybe, like that's the b.
Yeah.
Right? But then what we do with this thing, like how do we apply n2 to it, right? And we have this, right? So we have the result of this, and we have an n2 which is a maybe int, right? So we kind of wish there was a way, like some secret function that we could say map n1 and 2 like this, right?
Yeah.
Oops. What am I even doing? Okay, right? And then do n2 here, and we'd get back a maybe int, right? I kind of want to take this int and put it in here as the argument here, and get the int back, like inside this function.
Yeah.
And it turns out that's what applicative does, or just that's what apply does. So let's look at apply for a second now. Let me like comment this part out. So we have class apply, and I will use it like this because it already exists, right? Apply with over some f, right? Because remember, like this is also the same here, like where is it? Functor f, right? So it's also apply f. Where is it? Okay, and then where? And we have a function named apply, which is for all ab. If you give me an fab and then fa, I can give you an fb, right?
Okay.
So like if you give me this, right, and then fa, I can give you an fb, like a maybe int.
Yeah.
Right. So instead, so we could do, for example, we could say apply of this, right?
Yeah.
Like this over this gives me a maybe int.
Yeah.
Right. And then if we were to, and there's one more thing here. It needs a functor. So we write functor f. If we have a functor f, then we can also have an apply f, right? It's kind of like a prerequisite. Like remember, like you needed semigroup before, and then you can do monoid.
Yeah.
It's the same thing here, right? You need functor first, and then you can do apply.
Yeah.
Right. So we have the functor instance for maybe because it's defined by the compiler here, right? If you remember, like we wrote this. Right. So let's try to write the apply instance for maybe together, right? So it's instance apply maybe where it's apply maybe, right?
Yeah.
Need to write this apply function, which is for all a b. I think I added an extra space here, and it's maybe a goes to b, and then maybe a, and then maybe b, right?
Yeah.
So let's think for a second. What do we do here? Well, like we can literally, like we can say this like maybe a to b, right? The function, and then maybe a here, right? And you can literally just do the same thing, may a to b ma, like this, right?
Yeah.
And say, okay, if I have just a to b, right? Because like if we look inside the maybe a to b, we can have a just a to b inside it, right? It's just this value inside it.
Yeah.
Okay, and some just a value inside, right? Then we can do just a to b of a. So this kind of looks a lot like functor, but the function is also inside the f, right? Remember, that's the only difference, because the functor just doesn't have maybe here, and everything else is identical, right?
Yeah.
Okay, and then in all other cases, we just return nothing. Right, and this looks very, very much like the way we wrote our implementations here, right?
Yeah, it does.
It's kind of the same thing. And then there's one more trick here. Let me actually name it apply prime, such that it doesn't get confused with the one defined by Purescript. Actually, let's do this. Hiding apply class apply and then this. Oh, sorry, because otherwise we'll have some trouble. Let's see, does this work? Okay, cool. And now there's this thing which Purescript does, which is super cool, which, and Haskell as well, which is it defines this thing, which is an operator, as for all FAB, if we have an apply F, and then if we have maybe A goes to B, maybe A, maybe B. So it's literally the same thing, but it gives an operator instead of right. And I think we can do this. What's the problem here? Enabled unexpected token. What did I do wrong here? Do I need to do this first? Like this? Unexpected. Something is wrong, but I'm not sure what. And the sun isn't not helping. Actually, it's been a while since I've played with Purescript operators, so maybe let's cheat and see how they define it somewhere, like how an operator is defined. Maybe we can even look at this one. Oops. Okay, so how is this defined? Because I forget. Oh, okay, so it's like, yeah, you can't even do that. Okay, I forgot. Oops. Okay, where is it? Okay. Okay, so this is how you do it. Okay, never mind. It's just like this. And then we have to use this thing. Okay. So what this does, basically, it's saying, okay, I want to define an operator, which is called this. And it should do the same thing as apply. Right? This is all that it does. And then there's also, that don't know the number for it, but map as this. Right? So you can use this instead of map and this instead of apply.
Okay.
Okay, so let's actually try to rewrite our sum function now. So I said that instead of map, we can use this operator, right? So we can use this here, and we do the map.
Yeah.
And then we can do this and use the other one.
Okay.
So this is what. Let me try to still scoot over. Am I out of frame now? Yeah, I'll probably be out of frame. If I do
a
this.
bit.
Let me try doing. Oh, whatever. I'll deal with it. I need sunglasses. One stream, like I legit need sunglasses. Right, so like this is it, right? And this is pretty cool, right? Because like we can even do concat now, like the concat version, and we can do concat. Yeah, I do need some curtains. I was kidding, right? And we can do this, right? S1, S2, right? And this also works. The cool thing is, like, let's say I have a function which adds like add 3, which is int to int to int. And then, well, it's x, y, z is x plus y plus z, right? What's the problem? What am I doing wrong here? Oh, it's okay. Sorry. It takes 3 ints, but it returns another one. Okay, so then we could probably, like, we can do some sum 3 here. Maybe int, and we could do sum 3, and then we could say, okay, add 3, right?
Yeah.
And then add n1, and then add n2, and then add like just 3 or whatever.
Okay.
Right, so like you can have functions which has with as many arguments as you want. You just add one of these extra, and then you can. It basically lets you do add 3 over like the regular numbers, right? Like kind of like when you do this, it kind of makes add 3 to work with maybes everywhere, and also return a maybe, right?
Yeah.
Okay. So this is what apply does, right? So in case of maybe, the idea is like if any of this is nothing, right?
Yeah.
Then the result is nothing, right?
Okay.
So yeah, this is how this is how the apply instance for maybe works always, right? If there is one nothing, everything goes to nothing. If everything is just, then you get a result back, right? It's kind of like if something is null, you cannot do the operation anymore, so you need to stop, right? That's kind of the semantics or the idea. Okay, so let's see then. We have this thing now. apply. Okay, and then there's one more thing which is called applicative. And the idea for applicative is it gives us one more operation. So we have something like class. So if we have an apply f, right, we can write applicative f. And then this gives us only one thing, which is called pure. And pure is just an, if you give me an a, well, for all fa, no, sorry, for all a, I think. So if you give me an a, I can give you back an fa.
Yeah.
Okay, so let's try to write an instance for it. So instance applicative maybe. Okay, so if we have an a, how do you think we can make a maybe a? So let's look at the maybe type, right? So how can we make a maybe? Like look here.
Yeah, it's a nothing or a just a.
So which one do you think is the one that we want here?
We want the just.
Yep,
right?
exactly, right? Because we have an a, right? If you use nothing, we'd not use the a there, right? So it's just a, right? Which means that, for example, here we could write pure 3 instead of just 3. What's the problem here? Oh, okay, because I used pure like this and okay. And then here we need to use this. Yeah. Okay. And like pretty much that's all there is to it about with maybe. So maybe let's look at what other examples should I use. So the problem is that the maybe is like a great example and it's very simple, but then most other examples are pretty complicated, unfortunately. So let's see, what kind of example can we do? Like the usual example is lists, but I think lists are a pretty bad example because their applicative instance is super weird. Okay, so let's do something else. Let's go to Monad, and then maybe you can go back and go through the same process with a different type later.
Yeah.
Okay, so now like the cool thing is here is that you can do things with like with applicatives in general, right? But since we only know one, we won't worry about that for now, right? So let's look at monads. So what can we do now with this? Well, we can kind of lift functions, right? Because this is actually the term for it, right? So it's kind of like, okay, we're lifting this function from ints to maybe ints, right? It's kind of, that's the official quote unquote term, lifting, right? Okay, so what if we have a different set of functions, right? So what if we have a like some function like let's give them different first. Let's use m this time, right? So let's say we have a maybe int which is called m1, right? Which is just 1, I guess. That's fine. But then we have some operation, right? Which is called op for now. And let's say it's something from int to maybe int, right?
Yeah.
And then for some number n, it does, I don't know, like n, well, if n is 0, then nothing else, n plus 1, whatever. I don't know why, just because, right? Yeah. Well, just n plus 1, right? It does some sort of operation, right? So I kind of want to, starting from this m1, right?
Yeah.
I kind of want to grab this int here, if it exists, and throw it in here and get this as the result.
Okay.
Like I kind of want to chain these operations, right? And let's say we have an op1 and op2. So again, if this is 1 or if this is 10 for whatever reason, then I want nothing. And I'm writing it differently just for fun, right? In other cases, I want it to be just show n, right? And that's fine, right? Yeah. Okay, so what I want to do is I want to take this m1, I want to put it here, but like I cannot really use it directly because it's a maybe, right? So I want to put this int here and get a result, but then out of this maybe I also want to take the int and put it here and get a maybe string at the end.
Okay. Yeah.
Right, so let's try
Yeah.
to write like the composition thing together, right? So at the end, I want to get a maybe string, right? That's the end result.
Mm-hmm.
But the thing is, now I cannot do case m1 op1 because this is a function, right? Like I cannot pattern match on it because it's a function. I need to call it, but I don't have an int to call it, so I need to do it like step by step. So bear with me because this is going to be ugly.
Okay.
So okay, if I have nothing, then the result is
Yeah.
nothing and we're done, right? If I have
Yep.
just like m1, the first value, let's do
Yeah.
v1 and we'll do v2
Okay.
and so on, right? Then
Mhm.
what do we do? Well, we can do op1 of v1, but what type is
Yeah.
this? Like what type is the result of this?
It's wait, it's a maybe in.
Yep.
Right?
But then we need the int from inside this to call op2. So now we need to do case this of, again, nothing, then we get nothing in return, right?
Yeah.
And then we get some v2, which is another number, right? It's this number.
Yeah.
And now finally we can call like op2 of v2 and we're done because this is string, right?
Okay. Mhm.
But then if we want to add another operation here, like op3 string to maybe string, for example, and then
Yeah.
here, let's say if the input, s equals, if s is hello, then nothing else, s plus, like we add this thing at the end, whatever, right?
Mhm.
Then what do we need? Well, again, we need to case op2 of v2 of. So if it's nothing, we do nothing. If it's just v3, then we do op3 of v3, right?
Yeah. Okay.
And again, okay, we need a just here, right?
Mm.
As
Yeah.
the result. Right, so like for every additional computation step we want to do, we go like we'll end up on a different like we'll end up with like somewhere
The
here,
next
right?
case.
In the
Yeah,
like on the next page, right? If we keep doing that, and this looks like something that like this looks like a lot of repetition, right?
Mm-hmm.
But it's sort of a different kind of repetition than the previous one, right? The types are kind of different than before because they are functions now.
Yeah.
Right, but like this kind of thing actually happens very often, right? Because like you read something from a database and then you like validate it with like some internal idea, and like what if it doesn't exist in the database? Then you'll get an error. What if the validation gets an error? Well, you need to stop. What if the user gives you water? Like this happens a lot, right? This step-by-step computation.
Mm-hmm.
So this is something that happens quite often, and like that's what Monad is here to help us with.
Okay.
So like how does this usually look like? Like how does this thing look like? Well, like we have a like if we were to give a type to this operation, it's something like, right? We have a maybe int, right?
Yeah.
And we have a function from int to maybe, let's say int, but some other a, right? Some let's call it b for now. And we want a maybe b in return, right?
Yeah.
Does this make sense?
Yeah.
But then why should this be int? It should be like for some maybe a, right? This?
Yeah.
Okay, so let's see. Do you think we can write this function? Rather, do you think this function is possible to be written?
I mean, in my honest opinion, I think it can.
Okay, do you want to try it or want me to write it?
It would take me a while. I think you should write it this
Okay.
way.
So, okay,
Yeah.
so we have some maybe a here and some function
Yeah.
here, right?
Mm-hmm.
Okay, so what do you think? Like, you don't have to write it, but what do you think we can do here? Like, what's the only thing we can do here? Like, can we do anything with this function?
No, not yet.
So only thing we can
we
do
need
is this, right? We can
Yeah,
pattern match
yeah,
on this.
yeah.
So like we can even write it like case ma of, right?
Yeah.
So if the result is nothing, what can we do here?
Nothing.
Right, so the result has to be nothing. And if we have just an a here, then what can we do?
We go to the next case because we need to get the value out.
So wait, this is a to maybe b, right?
Yeah. Yeah.
Okay, so we have an a. What if we do a to maybe b of a? What type is this?
It's a B. It's a maybe B.
And what do we need to return?
A maybe B.
So we're done, right? We don't need to pattern match on this.
Yeah.
This is a maybe B, and this is also a maybe B, but it's the nothing from maybe B, whereas this is the nothing from maybe A, right?
Yeah.
So like that's the function. That's all you need to do, right? And now we can replace composition. Well, let's write it here so it makes a bit more sense.
Okay.
As maybe string, right? And we can write it using this fn helper here, right? But let's give it like an operator name, and you'll see in a second why I want to do this. Where is it? I never remember how to write this. Okay, and then let's call it like let's use 4 of this, right? And then let's call it fn. Okay. So we actually can write this as, okay, so we have an a maybe A, which is our M1, right? So we can do M1.
Yeah.
And then we can go to OP1, right?
Yeah.
Because this is a function. But what's the result of this? Is a maybe int, right?
Yeah.
So if this is a maybe int, can't we just use the same operator to go to OP2? And then to OP3?
Okay.
And turns out we can, and that's all we need to write. So all of this, just using this little cute thing here, can be rewritten as this. Right? As long as, like, okay, this type needs to match the input for this, and the output for this needs to match the input for this, and the output of this needs to match the input for this, right?
Yeah.
But if all of these match, then you can just write it like this. And this is like we've literally just discovered bind, right? Bind is a class. I think you need apply. I think you just need apply. Let me see, because it's a bit like there's a bit of a difference between Haskell and Purescript, and I sometimes mix them up. So let me see. My intuition is that bind only needs apply, but let's see. Yeah, it only needs apply. Okay, cool. So if we know that we have an apply f, and we usually call this m, like we usually, like, this is just convention. We can call them f or x or whatever you want, but like applicatives and functors, I usually you usually use f, and then for monad and bind you usually use m as a type variable.
Okay.
But again, it's just convention. You can use whatever you feel like. So bind m where, and we have this function called bind, which is literally there is a sun person behind you. Watch out. Oh yeah. Yeah. Praise the sun, I guess, is the title for for this stream. Right. So let's see. Looks like eyes to me. I wonder where. Oh, I think where. I'm not even sure what is like. Yeah, I have no idea what's it hitting. I think it's like some branches over there, which is super weird. Anyway, so for all A, B, if we have an MA and A to MB, and we get an MB at the end. Right, and it's like literally the same thing here, except we replaced maybe with M.
Yeah.
Do you see it?
Yeah.
Right, so now we can do instance maybe bind, which is bind maybe. Or bind is, we can just say bind equals to fn, because we already implemented it. It's just the same thing, right? Right. This is like we could copy paste this here. It's the same thing, right? And the thing is, this actually has a different. It has an operator, but it's different than this one. And I wanted to use I wanted to introduce it now, and it's it's this one. Right, so actually the real operator that we use is this, right? In Purescript, and not this one. I'll just delete this one now because I don't want you to remember that one, right? So it's this. Okay, and this is how we can write composition, right? And then there is one more class here, which let's do for completeness, which is called monad. And then it's monad. Well, now, what am I doing? So if we have both bind m and applicative m, then we have monad m. But that's it's class. But that's it. There's no extra. Oops. I think that's how we need to write it. Yeah, but like this doesn't give you anything extra, right?
Okay.
But this just makes it so you have both this and pure and apply, right?
Yeah.
Okay, and now the super cool thing here is that, and I'm not sure that will work. Let's see if it will work. If it won't, then I think we'll have to remove this part. So let's see. The cool thing is we can now do composition, another version of composition. So this turns out to be actually so widely used that it has special syntax support in Purescript. So you can do something like A is MA, and you can think of it as like within this do block, but you cannot do this otherwise. Only inside this block, you can take things out of the maybe. So this is actually a type like an A. We can take out the value, right? But what happens behind the scenes? Well, if this is a nothing, then the do block just stops. It doesn't go further, and it just doesn't have the value, right? But if it has the value, you can get it here, right? And then you can get the B from like OP1 of A, and then you can get the C from OP2 of B, and then we can get the D out of OP3 of C, and then we can do pure D at the end to return it. So let me see because I'm not sure this will work. So unknown value. Oh, because it's M1, okay. And then the problem is we don't have a bind. And it needs to be that specific bind. Okay, so what we'll do now is we will stop hiding stuff, and I will actually use the real. I will comment out the classes that we defined, because they already exist in Purescript, but they're just without this thing, right?
Yeah.
So I'll just define them for real for this thing, right? And also we don't need this because it's already defined. And we'll go up and do the same for applicative, and then remove this, and then the class already exists, and then this thing apply. I think it should work now. Yeah, there we go. Now it works, right?
Okay.
So oh wait, there's still a problem here on the oh, because I still have hiding, but I'm not hiding anything. Okay, I think this is okay. There's still one problem here. Okay, we use pure prime here. Okay, there we go. That's it. We fixed everything. Right. So like, okay, it's easy if they're exactly sequential like this. You can write it like so, but that will not always be the case. Sometimes you have to do like maybe B prime is also OP1 of A. Maybe you need to do two values for whatever reason, right? Like if you cannot, like this actually looks a lot like a C program, right? Because you run things in order, and then you can like call them and get things out of maybes, and then call them and so on, right? Like this is something that like you write instructions one by one, right? Whereas normally like you write equations in Purescript, right? These are all equations, right? But this actually is more like line by line instruction. So this is more like, this is a very imperative style of writing code, right? So yeah, I mean, that's what monads are, or at least that's how the maybe monad works. And again, the trick is like all of this, like on the right hand side of this thing, of the arrow here, right? So let me try to explain the do syntax for a bit, right? So here you have to have a maybe, right? So this is a maybe int. So then I'm getting back this A, which is like A in this case is of type int, right?
Yeah.
So I'm taking the value out. But then this is a function, right? From int to maybe int. So when I apply the value A, this also turns out like the whole thing is also maybe, right?
Yeah.
And so on, right? So this is kind of like shorthand notation for this, pretty much, right? For initially for this, but then for this, right? Except you can kind of mix and match them easier, right? You can like they don't have to be like to match the inputs and outputs so nicely, right? Okay, so let me explain something else. So for example, here you could do something like let a prime equals to a plus 10, for example, and you can use a prime here instead.
Yeah.
Right. Which is like which makes things a lot easier, right? You can so this doesn't have to be in maybe, right? So you can use let to do things that are not inside them, like the maybe thing. Right, and declare variables here, and then you can like use them and so on, right? Which makes it pretty easy to work with. Yeah, so let me think. So chat, what do you think? What's a good example of a second monad to work with? Because identity is useless, so it will not give us too much info. Maybe I think is the best example, but we've gone through that. And then we could do either, but then either is only a bit trickier because but it has this kind of the same semantics as maybe. It's very, very similar, except it just has two type variables. And then lists are very different. Maybe list is not such a bad idea, because I want to show that actually like this idea of but maybe lists are a bit too complicated for now. Let me look at the plan, because I think we have effect for next time, so I don't think I show you effect now.
I think we do.
Yeah, effect is next time. Okay, let's just do either then. That's totally fine. We can do either. Okay, so let's do a new type now, right? So let's do data, either AB, or let's do XY again, just so it's easier, right? So if left X or right Y, right? And like this is defined in some library, but we'll just define it manually, right? So then we can do this thing, right? We can derive the instance automatically. Oops. I think like so. Yeah. And now we can try to write the instances for everything else, right? So let's do apply either. Okay.
Yeah.
So it's apply either of X, right? It's exactly like functor. Like if there's one more variable, then we need to like put it here, right? The same idea. We have this function, and I will write the signature, and then we'll try writing the implementation together, right?
Okay.
So the signature is this either. So like the generic signature is this: apply f of a goes to b, and then fa, and then fb, right?
Yeah.
So then what's our f? Our f is either x, and then a goes to b, right? Yeah. And then it's either xa and either xb, right?
Yeah.
Okay, so it's okay. This is the either x a to b.
Okay.
We wanted to write it like this, so it's easier to understand.
Yeah.
And then this is either x a, right? Okay. So what do you think we do here? And you don't have to type if you don't want to, or you can take control if you want to, or you could just say like, what do you think we can do?
Well, okay, so hear me out. I feel like this is already done for, and all we need to do is the output. So I have to somehow use the value. Okay. This is the syntax is killing.
Well, actually, it's a bit tricky because I like, again, this syntax is slightly trickier. But like, let's think about it for a second. So what are the options? So we either have so if we have right and right.
Yeah.
Like if both of them are right, then we just put the A inside here and get a right B at the end.
Yeah.
If they're different, then I don't know. We have to figure out what we do, right? We'll think about it.
Yeah.
Let's say that's the answer. We'll think about it. Okay, so but like the answer I was looking for, and I guess you already were thinking about it, but just didn't say it, is the only thing you can do is we can pattern match, right? As pretty much usual. But then since we have two eithers, we could just pretty much, we could just pattern match on both at the same time, right? So we could do case ex this and then ex this off, right?
Yeah.
And then we talked about the first case, right? The easy case is, okay, if I have a write A to B and the write A, right?
Yeah.
I could just do write A to B of A, which is kind of like the functor instance, except it has the extra write here.
Yeah. Yeah.
Right? And then, okay, so what other options do we have? Well, in other options, we have either a left here or a left here.
Yeah.
And in both cases, we want to return the left. This, I think this instance is left biased. I'll check. Let me check, actually. I think it's inside either. Pretty sure it's left bias for this. Which means that if we have two lefts, we return the... Oh, no, actually, we can't. Oh, yeah, we can. Never mind. So is it left biased? By functor. Wait, is the... okay, where's the apply? So if we have a left here... Yeah, it's left... yeah, okay. So let's go back. Oops. So, okay, so if we have a left here on the left-hand side, x, right? And whatever we have on the right, we just return the left x, right? And then if we have a left here on the right, then we just return it. Oops. So, like, we could have a left here as well, but we ignore it. Right? Like, if both of them are left, then we just return this one, the left one.
Yeah.
The left.
Yeah.
And that's the instance. That's it. Oh, and we forgot to do for all x, a, b. Here. Right? So that's the instance. So what's the semantics here? Well, again, we usually, like for either, we usually say that the left-hand side represents errors or like the exceptional case that shouldn't happen, right? So then, okay, if we have two rights, then we carry on as usual, right? We just apply them one to another. And if we have a left, then we stop. It's kind of like if we have a nothing, we stop, but instead the left has some information as well, but we just keep it, right? Okay, so what about applicative? So let me remind you here, we have a for all B, A, and we have from A to either XA, and then we also need an X here. So what do you think we do? What do you think we do here?
Do we go for the case again?
Well, like we only have an A, so we cannot pattern match on A.
Yeah.
So okay, we need to construct an either. Which one can we construct?
It's the left one because we have the X, right? Wait.
No, we have an A, right? Not an X.
Yeah. So the right.
Yeah, so we can only do this, right? There's no way to do anything else here.
Yeah.
Like it has to be this. Okay. So then let's see. We want to have two more instances. Bind either. So bind looks like this for all A, B, X. Let's do X, A, B like on top. And then we have this. We have either XA, right? And then we have a function from A to either XB. And then we need an either XB as a return. Right? Because like it's either X everywhere, and then it's an A function from A to the B inside the context, and then the result is a B inside the context, right?
Yeah.
Okay, so this is either XA, and this is a function from A to either XB, right? Okay. So what do you think we can like? What can we do here?
Okay, give me 1 second. this is where we go for the cases,
Mm-hmm.
because there are a lot of values.
Uh,
So,
okay.
what, did I do something wrong?
No. That's fine. That's fine. That's good. Okay.
And,
Yep.
to-
Well, we cannot pattern match on A because it's a function, right? So we can only pattern match on this one, on the first one, exa.
yeah.
Okay.
Okay. So
And then like you can do
exa.
off,
Yeah, off.
and then a new line, and then okay, let's see. Like what can we have? We can have a left, right?
Mm-hmm.
So what happens if we have a left x?
If I have a left x, then I have to. Okay.
Like what's a result type? Can we like?
It's a x and b
Mm-hmm.
from.
So we have
So-
this function, but there's nothing we can do with an x here, right?
Yeah.
There's nothing we can do with the x further, but like we can just return the x.
Yeah. Only the x, right?
Mm-hmm.
Yeah.
So like it's this, right? Left x goes to left x.
Yeah. Sorry.
Okay.
Mhm.
Right, because like if this is left, then the result will be left. We cannot do anything with it.
Yeah.
Okay.
Yeah, okay.
So what if we have a right a?
If I have the right a.
Like here, right a. What can we do here?
Well, I can do this one.
Mm-hmm.
The a goes to either xb.
Mm-hmm.
So,
I mean, okay. So let's just
It's
just type that,
like-
yeah. And then
Okay.
call a. Okay, so what's the type of this thing now? After you call
it's
it,
now after I call it, it's a either.
what type of either? So it's either x and what?
X and a. Right.
Why? Because it's this function, right? So it's this thing. So we gave it an a, and now it's what?
It's this one, the either
Mhm.
xb. Yeah. Mm-hmm.
And which is exactly what we're trying to return. So that's it. We're done.
Okay.
Right?
Yeah.
Like
Mm-hmm.
that's it. That's all we need to do.
Okay.
And then we have the trivial instance up monad either, which is just monad either x, and that's it. We don't need to do anything else because like this only needs for this and this to exist,
Mhm.
right? And then this also works. Okay, so now let's play with some examples. So let's say we have let's use e1, right? It's an either string int, right? So e1, let's say it's right 1, and then let's use f1 here. It says int to either string int. So let's say that this takes a number, and let's say x. So let's say if x is smaller than 0, we will return left with cannot deal with negative numbers, and then otherwise right with x times 2, whatever, right?
Yeah.
Like so. Oops. Okay. Yeah. Then let's just do two functions, right? And then we go from int to either string. I don't know. Let's do string. Oops. And then let's also do like something similar if x is greater than 10. Well, let's do this. Whatever. And then do otherwise right show x. Right, and now we can do like some test function, which is either string, I guess. And we can do something like this, right? We can use do syntax, for example, right?
Yeah.
Actually, let's make it. Okay, let's add one more function in between here. So let's do f2 here, and let's have this f3. So let's say this is from int to either string int, and let's say f2 of x and y. If x plus y is 10, I don't know why, don't ask me, it's just a silly example. Let's say something like this, right, where that adds them, right? So let's say we have like v1 is e1, right? Or let's just say a is e1. And then let's say we use this twice, right? Let's say we get like b is f1 of a and c is f1 of a plus 5, whatever. And then we can do d is f2 of b and c. And then we can say e is f3 of d. And at the end we can return pure e, for example. What's the problem?
Test
Oh, we've defined it before. Okay, so let's use this then. Right, so like you can combine them like in a lot of ways here, right? We can say, okay, so this line, we take the int out of the e1, right, and that's a, and then we call f1 with that int, right, and we get b, and then we call f1 again but with a plus 5. Why not, right? And we get c, and then this one takes 2 arguments, so we give them 2 arguments, right, for f2, and then we get back some integer, and then like for e we just get this integer and put it here and get a string back, right? But if any of them fail, we'll get that first error, right? So if this one fails here, then the rest doesn't even happen anymore. The result is just this left string, right? Because we can do this. Right? Or like if anyone fails, then the rest of the other ones stop. They just don't get called anymore. Which is very similar to what happens with nothing, right? Except with nothing, you only have nothing, right? With either you also have like an error message here, a string, something else in this spot. But the idea is similar. Okay, so now I have to think about what kind of homework to give you. Which is kind of tricky because like I cannot give you to write different instances for applicatives and monads and so on, because those are way too hard for types that you're not familiar with.
Okay. If there are no exercises, I don't mind having something to read. Maybe, I don't know.
Okay, yeah, actually that's a good idea. How about you try like okay, so let's do this. Let me fix your thing now, like to have your Purescript compiler work locally. And then you can like go through let me have a look at this actually. So
how do you want to proceed with fixing?
So that's up to you. If you're comfortable sharing your screen on Discord and me showing that screen here, I can do that. If you'd rather do that offline, if you're scared that you'll leak something, then we can do it after the stream. I have time. I have a few minutes after the stream.
It's fine.
Okay, so first off, you can figure out that while I'm looking at the Purescript by example book and seeing if there's something that type classes applicative effect monad. Okay, let me look at type classes and see. So it's show, EQ, horde fold, foldable. Oh, and it goes into foldable, which we've not done, so we can probably skip that. So is there stuff with the... Oof, this goes way too hardcore. Yeah, and then it goes into effects. I've done so. Oh wait, it doesn't go directly to effects. Yeah, but these examples, I think this XML thing ties to the previous thing. So if you haven't done the book, Hello, sorry for being late. Hello, Hysterius. I mean, we're kind of winding down now, but you can probably watch the VOD or the YouTube in a few days. Sorry, but monad laws, identity laws, folding with monads, monads and applicatives. It's all kind of what it says. Write a function third which returns a third element of an array, 3 or more elements. Write a function. Yeah, these are with the arrays. Okay, you know what I'll do? I'll give you like one video and one article. And the homework is for you to read those for next time. Like look at the video, read the article. And the video is the recent video that probably some of the chat is familiar from Reddit. And like it's been all around. It's actually a pretty good introduction to monads. It's in Haskell, but it doesn't matter. You won't even notice the difference. And then there's an article which is called, I think you could have invented monads, which kind of explains in a similar way, I guess, but it doesn't hurt to see a different kind of an explanation. And then I guess that I guess that's I don't think we can do too many exercises here. And I think next time after we do effects, like I'll explain effects really fast, and then we'll start writing programs.
Okay.
Right. So less homework this time. If you want, like you can go through the Purescript book if you want, but you need to start from the beginning.
Yeah, of course.
So you can try going through it from the beginning, and like you can go fast if it's easy, if it feels too easy, but maybe try copy pasting stuff from like running things and so on. And like there's some explanation here how to get started and so on. So try to make sure that it works for you. Okay, so let me see. Watch stream. Okay, let's see how we do this. So how do I make this full screen? Like this? Yeah, okay. Let me move this over here. Let me full screen it. Oops. Okay, so I think I can see it. Okay, so you're not inside the project, which is, I think that's the problem. So why don't you try this? Let's create a new project, or maybe open folder or create a new folder or whatever.
New file? Yeah.
No, it needs to be a folder. Like you can use the open folder there or like create or something.
Yeah. Wait. Okay.
Okay.
Did it open another editor and now I have to share the screen again?
I think I'm seeing the other editor. So can you expand the... Oops. Can you expand the... Oh, actually I'm not sure. Like I'm seeing an empty editor right now.
Do you see the start new file?
Yep, that's what I'm saying. Okay, so then I guess what you need to do is create some like directory here, some folder.
Okay, well, I open it, right? The new first one that I just created.
Yeah, I keep clicking the wrong thing. Okay, but then I'm not seeing it on the left-hand side.
It doesn't do anything. Maybe this? No.
Oh, okay. That's
here.
correct. Okay, yeah. So you need to do like the next one, the new. Actually,
new
no.
file.
So do Control tilde to open the console. Okay, there we go. And now, so that's the directory you want, like the new Purs thing.
Yeah.
Okay, so type there Spago init. Okay. It should be creating some things here. Okay, cool. So now you just need to copy all your Purescript files inside the src folder here.
Okay, I understand now.
And after you've copied them all here and you do like save or build or whatever, then it should take. Like try doing that now. Like let's copy at least one file here and see.
Okay. Wait. Do I go new file?
You can drag and drop it, I think, from a different instance. Okay. You can, I think you can even copy paste. You can create a new file and then copy paste its contents, however you like.
1 second. Oh. Okay, I forgot where it says. Let's see, users. Wait, one second, please.
Sure.
Okay. It says it's an open editor.
Oh, so it doesn't let you drag it. What about,
No.
do you have copy yeah, can you right click on it again? Is there a copy file or copy relative path? No. Okay, so just copy the contents, I guess, or... Oh, I think if you reveal the contents in Explorer, you can drag and drop from Explorer to here. So if you right click on the file...
Yeah.
And then, like, no, not like the one on top, yeah. And then reveal file in Explorer, like I think the second one. Then you can drag it from Explorer to the SRC folder, I think.
Yeah, that's what I tried, but it opens it in here.
I mean, I'm seeing a main.parse, which is below, and the part 6.parse, but they're not in the SRC, they're in the main thing.
Mm-hmm. Yeah, I can't...
you can drag and drop them from down there back up. Like you see the part 6, which is there. Wait. So look at your left hand side in your editor. Down. There's also part down.
Ah.
Right. So it just put it there, right? So you need to put it inside SRC. There you go.
Okay. Okay. Sorry.
Okay. So now, like, if you open it, okay. So what if you save it? Do you get errors now? Yeah, you see, like, it's down there. There's an error. Okay.
Let me just get rid of it. So.
Well, no, the error is up. It's above. You see, you have an equals there, but there's nothing on the right of the equals, like above the length part.
Yeah.
So you just do 0 or whatever. Just type 0 there,
okay.
And then it should fix that error. And then you have another one down there, but at least now you definitely see errors, right?
Yeah.
You need some spaces here, but again, like, it definitely works. So.
Okay, now I have all the errors that I
that you ever dreamed of
before. Yeah.
Okay, so one thing we could do is, for example, we could set up. So let me see. What if we? So, do you have any? So, one other thing we could do is, because this thing that I have here is on GitHub, so we could just set up the GitHub repository. So you have exactly the same thing that I have now without you having to copy paste anything. Do you want to do that?
Yeah, we could do that.
Okay, so let's do that really fast. So let me, like, commit everything. Why isn't this staging everything? There we go. Okay, done. Push. Okay, so but then that means we need a yet another, like, you need a new directory now.
Yeah.
So, like, do the same thing as before and open a new directory or folder or whatever it's called.
Yeah.
And still seeing the old window. Okay, there we go. As the new one has opened up. Okay, so let me see. Is there a way to do this easily from here? No, just open the console, like Control tilde again. Okay, and then just type Git Clone. Git Git.
Yeah. Sorry.
HTTPS :/ okay, github.com.
Yeah.
/Vlad Ciobanu, and now I have to remember what the name of the repository is.
Okay.
Let me look it up because I will not remember. Repositories. I think I just pushed it, so it should be pretty top. Yeah, teaching-purescript. So /teaching-purescript.
Yeah.
Okay, and just hit enter. Okay, so you don't have Git on the command line here. So how about you go to extensions on the left hand side? I think it's the, like, square thing there. Yeah. And just do git. Yeah, just type git there and just get git what triggers GitHub within its workflow. Let me see. where is my Ubuntu thing? So was it Gitlance? Yeah, Gitlance. But can it clone? I think it should. Okay, try Gitlance, LENS, because I think I like that's a pretty good like regardless pretty good Git.
This one, Gitland.
Yeah. Just hit install.
Okay.
Like there's a green. Yeah, there we go. I think you need to hit reload after it's done, or no, actually it does it automatically. Okay, let me make this big so I can see it better. Okay, so now on the left hand side, on like where you click the squares thing.
1 second. Gitlance was unable to find Git. Please make sure Git.
Oh, so you have to manually install it. Damn. Yeah, I guess you need to install Git. I don't think there's a way around it. I mean, I guess all you need to do. Okay, so you need to install Git like on your system, like as an installer, Windows installer or something, right? And after that, you just need to run that command that you have in the terminal now, like Git Clone and that thing, and it should work. And then you should have everything there, and then you can do just like spago build, and it will just work in the console.
Okay.
And if it doesn't, just please message me like today or tomorrow, and I'll help you fix it.
Yeah. I'm just happy I have the errors again, because I didn't understand what I was doing wrong, because I was saving it as a Purescript file. And
no, like you also need a project, right? You can't have just freestanding Purescript files. That's the trick.
My bad.
Okay. Cool. Well, I mean, yeah. So I'll link you. Let me actually try to find it right now. So I think it's on Reddit. Let me move this out. You can stop sharing if you want. Okay. So let me find that. Let me go to this thing here. Oops. So it should be pretty high because I think it just popped up today or yesterday or something. So what if we look at top from the last few days? Past month, past week maybe. No. Pandoc. Oh, this one. Okay, I found it. So I'll just link it in chat, and you can grab it from Twitch chat.
Okay.
Whatever. Okay, so this is like it's literally a 5-minute video. So wait, what did I? Okay, I think I clicked the right thing. And then you could have invented monads. This one, I think. Okay, so yeah, try reading this. I think it even has exercises, so you can try implementing them if you want. Note that the syntax will not always work. The thing that will most likely fail is they will not use explicit for all, right? So when you see like A to B or whatever, just do for all A, B, and that should fix the errors. And and definitely whatever you do, try compiling from now on, right? Try compiling, try figuring out the errors. If you get stuck, then just tell me or like ask somewhere. You can definitely just ask me. Okay. And like this is a pretty lengthy, like as you can see, I'm scrolling and scrolling. Oh, actually, there's a lot of comments. It's not that big. Okay, it kind of stops somewhere here. Anyway, like you don't have to understand every little thing here, but just try going through it once and seeing if you can do some exercises and get some better idea. And again, as I said, you can start working through the Purescript book from the beginning. And yeah, let me know actually if you run into anything that doesn't work from there. Let me know because we can update it. That's
I'm prepared now.
We'll fix it. Okay, cool. So yeah, I guess that's it for today. So yeah, I guess again it's hard for you to have questions now. So but if you have questions until next time, then just again don't be shy to message. Yeah, I guess that's it for today.
I just wanted to say what I always do is like I try to go at least once through the entire VOD at normal speed and try to understand everything you told me because it's a lot to chew on.
Oh yeah, I know. I know it is, but like I'm also trying for it to not be boring at the same time, right? If we were going too slow, then
no, it's not.
So yeah, I guess like the thing is, I think the next few times we'll probably focus on just writing code. So that's where we kind of take a deep breath and start doing things. And we'll also learn some little things here and there, but as we need them. But it will primarily be let's start using all of the things we've learned so far.
Okay.
So there's still some like slightly more advanced topics, like beginner advanced topics, but I think we can dance around them for a while, at least until we write bigger programs, right? But if we write simple programs, then yeah. Okay, cool. Then I guess I'll see you next week.
Okay. Well, thank you for having me. Goodbye, guys.
My pleasure.
Thank you for watching.
Bye.
Bye.